0300 hours. My pager is going off again. AWS US East 1 is having widespread issues. And one of my Fortune 500 clients has their entire production environment sitting in that one region. Single point of failure, all their eggs in one basket. We scrambled. Within 2 hours, we had traffic routing to their Azure environment we had set up 6 months ago, earlier for disaster recovery. A DR environment they'd questioned spending money on. That night, it paid for itself 10 times over. That's when I learned what the Navy taught me years before. You need redundancy, but you need it done right. Not just duplicate systems, strategic, intentional, disciplined redundancy. Welcome back to Faith, Freedom, and Tech. I'm Scott Houghton, DevSecOps engineer, cloud architect, and today we're talking about multi-cloud native design. Building bridges, not walls, between AWS, Azure, and GCP. Quick background for those just joining us. I've been in tech for over 20 years, started programming at 11. I've worked at Google Cloud PSO, AWS ProServe, with McKinsey, PwC, Deloitte on Fortune 500 transformations. I speak all three major cloud languages fluently, AWS, Azure, and GCP. And here's the thing. Multi-cloud isn't just a buzzword. It's a survival strategy when done right. But I've seen it become expensive chaos when done wrong. Today, we're covering why multi-cloud matters and when it doesn't. The three major clouds, their strengths and weaknesses, when to use each one, cloud native versus cloud agnostic approaches, Terraform and OpenTofu for infrastructure as code, real patterns that actually work in production, disaster recovery, data residency, vendor negotiation, best of breed architectures. We'll look at the well-architected framework, principles across all three clouds, common mistakes I've seen, and a practical implementation roadmap you can actually use. Look, I'm not here to sell you on multi-cloud. Sometimes single cloud is the right answer. Sometimes it's the only answer that makes sense for your team, your budget, your situation. But if you're going to do multi-cloud, let's do it right, not the half-ass way most organizations attempt it. So first off, why does multi-cloud matter? First, vendor lock-in is real. Prices change overnight. I've seen it happen. Services get deprecated. Regional outages take down entire platforms. And when you're negotiating your cloud contract, having options gives you real leverage. Second, compliance and data residency. EU data must stay in the EU. GDPR is an option. Governmental requirements, industry regulations, customer demands. Sometimes you need data in a specific region that your primary cloud provider doesn't serve well. Third, best of breed approach. AWS leads in the breadth of services. They've got everything. Azure owns the enterprise and Microsoft ecosystem integration. If you're already deep in Microsoft, Azure makes sense. GCP excels at data, machine learning, and analytics. BigQuery is phenomenal. Use the right tool for the right job. But, and this is important, here's when not to do multi-cloud. Small teams without the expertise. You need people who understand multiple platforms. Startups needing speed over resilience. Move fast, validate your product, then worry about multi-cloud. Simple applications that don't need the complexity when compliance doesn't require it. Don't let your consultants sell you on complexity you don't need. I've been that consultant. I know the game. Sometimes the honest answer is, you don't need this yet. The real challenges with multi-cloud, let's be honest here. Increased complexity. You're managing multiple control planes, multiple billing systems, multiple support relationships. It's harder. Skills gaps. You need experts in multiple platforms. That's expensive, hard to find, hard to retain. Networking nightmares. Connecting AWS to Azure to GCP securely with good performance without breaking the bank. And that's where most organizations struggle. Identity and access management across clouds. Different IAM systems, different concepts, different APIs. Federation is possible, but complex. Cost management becomes harder. You've got 3 different billing systems, 3 different pricing models, 3 different reserved incident strategies. Monitoring and observability fragmentation. How do you get a single pane of glass across all 3 clouds? These are real problems. I'm not going to sugarcoat it, but they're solvable if you approach it with discipline. So let me give you 5 multi-cloud patterns that actually work in production. These aren't theoretical. These are patterns I've implemented and seen succeed and can recommend with confidence. Pattern 1, disaster recovery multi-cloud. Here's the scenario. Primary production in AWS, disaster recovery in Azure. Why would you do this? Different fault domains. When AWS has issues, Azure probably doesn't. You've got negotiating leverage with both vendors, and you're covered for regional disasters. How do you implement it? Data replication strategies between clouds. You need to think about what RPO and RTO, recovery point objective and recovery time objective, and how much data you can afford to lose. How long can you afford to be down? Test your DR regularly, monthly, not yearly. Most organizations have untested DR. That's not disaster recovery. That's disaster fantasy. You're just paying for expensive backups you hope work. Automation is crucial. If your DR failover requires manual intervention at 3 a.m., it's not going to work well. Trust me on this. Pattern 2, data residency and compliance. Here's the scenario. EU customers on GCP Europe, US customers on AWS regions. Why? GDPR, data sovereignty laws, compliance requirements, customer contracts that specify where their data can live. Implementation means regional data isolation. Keep EU data in EU. Keep US data in US. Cross-cloud identity federation so users can authenticate once. Compliance automation so you're consistently validating you're meeting the actual requirements. And understanding data gravity. Data wants to be close to compute. Physics still matter in the cloud. Lessons I've learned the hard way. Trying to optimize costs by putting all your data in one cheap region, then paying massive egress fees to get it to where it actually needs to be, that doesn't work. Plan your data architecture first. Pattern 3, best of breed architecture. Here's your scenario. Azure for your enterprise applications because you're a Microsoft shop. AWS for your web services because their compute and content delivery is excellent. GCP for your data and machine learning workloads because BigQuery and their ML services are top-notch. Why would you do this? You're playing to each cloud's strengths here. But this is the most complex pattern. Only do this, and I can't stress this enough. Only do this if you have the team and the business need. Implementation requires a service mesh for cross-cloud communications, API gateways as an abstraction layer so your applications don't know which cloud they're talking to, centralized logging and monitoring across all 3, and CI/CD pipelines that work across all three clouds. Now, here's the reality check. This is hard. This requires significant investment in tooling, in training, in operational excellence. Don't attempt this unless you've mastered single cloud first. Pattern 4, hybrid cloud. That's cloud plus on-prem. So here's our scenario. Sensitive data stays on-premise. Burst compute to the cloud when you need it. Legacy systems that can't move stay on-prem. New development goes to the cloud. Why? Security requirements, compliance requirements, legacy systems that are too expensive or too risky to migrate. Or sometimes cost. Keeping workloads on-prem can be cheaper if you already own the hardware. So implementation options. AWS Outposts brings AWS services on-prem. Azure Stack does the same for Azure. Google has Anthos for hybrid and multi-cloud Kubernetes. You need VPN or, preferably, dedicated connections. AWS Direct Connect, Azure Express Route, GCP Cloud Interconnect. You need identity bridging, connecting your Active Directory to Cloud IAM. And you need consistent tooling across hybrid so your teams aren't learning completely different ways of working. In the Navy, we had redundant systems in different compartments. Main 1 forward, main 2 out. If one goes down, the other keeps the ship moving. Same principle here. Isolation with communication. Redundancy with purpose. Pattern 5. And this is the foundation for all of them. Cloud agnostic tooling. Terraform and OpenTofu. Infrastructure as code that works across AWS, Azure, GCP, and on-prem. I've been using Terraform since version 0.11. It's matured significantly. OpenTofu is the open source fork that's gained a lot of traction recently. You write your infrastructure as code, modules for reusability, version control your infrastructure the same way you version control your application code. State managing is challenging at scale, but solvable. Kubernetes, EKS on AWS, AKS on Azure, GKE on GCP. They're all Kubernetes under the hood. Your workloads are mostly portable. Service meshes like Istio or Linkerd can handle cross-cloud communications. We covered Kubernetes last week in episode 4. Kubernetes like a sailor. Same orchestration principles, just different underlying clouds. Modern stacks work everywhere if you do it right. Prometheus and Grafana are open source, work across all clouds. Datadog and Dynatrace if you want commercial options. Centralized logging with Elk Stack or Splunk. Distributed tracing with Yager or Zipkin. These are the tools that let you build once and deploy anywhere. Well, mostly. There are always cloud-specific considerations, but the 80-20 rule applies. 80% of your infrastructure can be cloud agnostic if you design it that way. Let's talk about well-architected frameworks across clouds. Here's something interesting. All 3 major clouds have well-architected frameworks, and they're remarkably similar in their core principles. AWS has 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, sustainability. Azure has 5 principles: reliability, security, cost optimization, operational excellence, performance efficiency. Google has 5 pillars: operational excellence, security, reliability, performance optimization, cost optimization. You see the pattern? They all prioritize the same things: security, reliability, cost optimization, operational excellence, different terminology, same concepts. The common principles that work across all three: design for failure, everything fails eventually. Plan for it. Implement security in layers, defense in depth. Automate everything you can. Manual processes don't scale. Monitor and measure everything. You can't improve what you don't measure. And iterate continuously. There is no done in cloud architecture. I can't stress that enough. I've had more organizations think that cloud is a one-time thing than I'd care to admit. Now, DevSecOps in multi-cloud. Security must be consistent across clouds. You can't have tight security in AWS and loose security in Azure. Your attackers will find the weakness. Policy as code with tools like Open Policy Agent works everywhere. Define your security policies once. Enforce them everywhere. Secrets management with something like HashiCorp Vault or cloud native options. Never hard code secrets. Network segmentation and zero trust architecture. The principles stay the same whether you're in one cloud or three. Security gets harder with multiple clouds. I'm not going to lie about that. But the principles stay the same. Defense in depth, least privilege, assume breach, automate compliance. Let me tell you about some real failures I've seen in multi-cloud implementations. I'm keeping these general for legal reasons, but the lessons are universal. The network nightmare. Organizations didn't plan for networking architecture. They ended up with IP address conflicts between clouds, overlapping subnets, no clear routing strategy. Fixing it required re-IPing major portions of their infrastructure. Expensive, painful, months of work. All because they didn't plan networking first. The identity disaster. Different IAM in each cloud. No federation. So users had different credentials for AWS, different for Azure, different for GCP. Security nightmare. Password reuse, weak passwords, no centralized audit trail. When they had a security incident, they couldn't even figure out who had access to what. The cost explosion. No unified billing view. No cost allocation strategy. Spend got completely out of control because no one was watching across all the clouds. They'd optimize AWS costs, but Azure spending had doubled without anyone noticing. The skills gap. Organizations try to go multi-cloud without training their team. Constant outages, misconfigurations, security issues. They were experts in AWS, beginners in Azure and GCP. That learning curve cost them in production incidents. The over-engineering. This one's my favorite. They used multi-cloud when they absolutely didn't need it. Added massive complexity for no real business benefit. It was multi-cloud because some architect thought it would work and it would look good on their resume. That's not strategy. That's resume-driven development. So what actually works? Start with one cloud. Master it. Really master it. Then add a second cloud with a clear business purpose. Not because it's cool, because you need it. Invest in training. Seriously, I can't stress this enough. Your team needs to understand multiple platforms. That's not optional. Automation from day one. Infrastructure as code. GitOps. Policy as code. If you're doing anything manual across multiple clouds, You're doing it wrong. Centralized visibility. One place to see logs, metrics, traces, costs across all clouds. Without this, you're flying blind. Let me give you a practical implementation roadmap. Phase 1, assessment. This takes 1 to 2 weeks. Do a current state inventory. Where are you today? What are your business drivers for multi-cloud? Why are you really doing this? Skills assessment. Does your team have multi-cloud expertise? Be honest. And budget reality check. Multi-cloud costs more. Is that in your budget? Don't skip this phase. I've seen projects fail because they're jumped in without planning, without understanding their why. Phase 2, foundation. This takes 1 to 3 months. Choose your clouds and your regions. Design your network architecture. This is critical. Get this wrong and everything else suffers. Set up identity federation. Implement infrastructure as code with Terraform or OpenTofu. Establish a monitoring and logging foundation. Create your security baseline. This foundation work is boring. It's not sexy, but it's essential. Rush this phase and you'll pay for it later. Phase 3, 3 to 6 months. Start with disaster recovery or dev test in your second cloud. Prove the concept before you go all in. Train your team on real workloads. Iterate on your automation. Find the gaps in your process. Document everything you learn. The pilot phase is where you learn what works and what doesn't. This is your chance to fail small, learn cheap, before production depends on it. Phase 4, production. 6 to 12 months. Migrate or build production workloads in your multi-cloud environment. Implement full observability across all clouds. Establish cost management processes. Regular disaster recovery testing, not once, regularly. And continuous improvement. You're never done optimizing. So some specific tools and technologies I recommend. For infrastructure as code, Terraform or OpenTofu. I'm leaning more towards OpenTofu now because it's open source, community driven, and has momentum. But Terraform is still excellent. I've used it a long time and it's a very solid solution. For CI/CD, Jenkins, GitLab, or GitHub Actions. Pick one that works across all your clouds. I'm probably less apt about Jenkins these days and a big fan of GitHub Actions, but GitLab's great too. Service Mesh. Istio if you really need it. But be warned, it adds significant complexity. Don't use it unless you have a clear need. I have seen many freaked out developers when I add 1,000 lines of YAML to their application for a service mesh. Monitoring. Prometheus plus Grafana plus cloud-native tools. Get the best of both worlds. Open source portability with cloud-specific insights. Security. Open Policy Agent for policies code. HashiCorp Bulletproof Secrets Management. Works everywhere. Cost management. Use cloud-native tools plus cube cost if you're running Kubernetes. You need visibility into spending across all platforms. 5 actions you can take this week. 1, audit your current cloud spend and contracts. Know where you stand before you make changes. 2, identify one workload that could benefit from multi-cloud. Start specific, start small. 3, start learning Terraform if you haven't already. This is essential for multi-cloud. 4, review the well-architected frameworks for the clouds you use or are considering. Really read them. They're free and they're valuable. 5, have the multi-cloud conversation with your team. Get alignment on whether this is the right move for your organization. Let me connect this with faith for a moment. Proverbs chapter 24, verse 27 says, prepare your work outside. Get everything ready for yourself in the field. And after that, build your house. Multi-cloud is about preparation. It's about not assuming everything will work always perfectly. It's about having options when things go wrong. And they will go wrong. That's not pessimism. That's reality and infrastructure. Ecclesiastes chapter 11, verse 2 tells us, give a proportion to 7 or even to 8. For you know not what disaster may happen on earth. That's diversification wisdom. Don't put all your eggs in one basket. Not in one cloud provider, not in one region, not in one availability zone. Diversify your risk. But here's the thing. Multi-cloud without discipline is just expensive chaos. And that brings us back to the theme from episode 2, DevSecOps and discipline. You need both the strategy, that's the multi-cloud, and the discipline, that's automation, monitoring, security, to make it all work. God uses everything, even production outages, even vendor negotiations, even the hard lessons from failed projects. Romans chapter 8, verse 28 reminds us, he works all things together for good for those who love him. Those failures I mentioned earlier, they taught me what you're learning today. They taught me what to avoid, what to prioritize, what actually matters. Let me wrap this up with key takeaways. Multi-cloud is a strategy, not a goal. A clear business reasons. Don't do it because it sounds cool or looks good on paper. Start with one cloud, master it, then expand with purpose, not randomly, intentionally. Automation and infrastructure as code is non-negotiable in multi-cloud. You cannot manage multiple clouds manually. It doesn't scale. It's not safe. It won't work. Networking and identity are the hard parts. Plan them first. Get them right. Everything else builds on this foundation. Well-architected principles across the clouds work. Learn them once. Apply them everywhere. And build bridges between clouds, not walls within your organization. Multi-cloud should reduce risk, not create silos. So look, multi-cloud isn't easy. It's not for everyone, but if you need it for disaster recovery, for compliance, for negotiation power, for best-of-breed services, then do it right. Build bridges, not walls. Use cloud-agnostic tools where you can. Master the platform you choose. And remember, the goal isn't to use every service from every cloud just because they exist. The goal is to build resilient, compliant, cost-effective systems that serve your business and your users. If this episode helped you understand multi-cloud better, share it with your infrastructure team. Check out my Medium articles at scottwhoten.medium.com for deeper dives into specific patterns. Join the conversation on X. And remember, whether you're building bridges between clouds or building bridges between people, the principles are the same. strong foundations, clear communication, redundancy when it matters, and the discipline to maintain it all. This is Scott Houghton reminding you that in tech and in life, putting all your eggs in one basket isn't faith. It's foolishness. Keep building, keep believing, and build those bridges. I hope you enjoyed this episode of Faith, Freedom, and Tech. If you did enjoy this episode, or if it helped you, like, subscribe, and leave a review. It helps others find us. Share this episode with someone who needs it. We're building a movement here. Find me on X at FT_podcast, or everywhere else at Faith, Freedom, Tech. Check out faithfreedomtech.com for show notes and more. Keep building, keep believing, and God bless.